Okay, I think we're on a roll here. So once you, I think we're having we're on a roll, we're on a wave, ride the wave, and capture as much as possible while on it, or something like that. But anyway, now the rule of 40 is the rule that any number plus 40 or minus 40 is considered the same number. So 40 is considered 80, is considered 120, is considered 160, 200, 240, etc. So this is to and when you have that rule and you know the gematrias of names, then all the information gets so concentrated, it gets so reduced. You can fit I don't know how to say it, but maybe like thousands of pieces of data. They're so compressed because numbers can represent so many words. And you might think that you'd forget those words or you'd forget the information, but amazingly, it sticks. It's something about it that it just holds it. It's almost like a circuit that holds something, or like, I don't know what the right analogy is, but like it's like a chip that holds data in it. And these numbers, they hold lots of data, and then once you have all this data that you're holding, you can put it in different contexts. You can have, this may sound a bit abstract, I can imagine. So let me give some concrete examples. Now, just to reiterate what gematriona is. Gematriona is the fusion of thought together with time, which means that you're using clock time as the engine that propels thought through gematria. Which means, and a practical example is right now, 3 minutes ago. Now, another rule is the 6-minute rule. The 6-minute rule is that within 6 minutes, either direction, either way, it's considered that same minute. Let's just say, right, 3 minutes ago was 7:13 p.m. here in Pacific Standard Time. And 7:13, we know, according to the rule of the 40, the rule of 40 in the PL-89, that 7:13 can be 7:53. And 7:13 can also be, now, if it's 7:13, it can be 7:53, but it may not be necessarily 53, wouldn't be the root. It only would be the root if it was 8:53 or 8:13. Why? Because 53 from 1 to 100 is, let's just say it's 53. And I'm going somewhere with this, so just, if you can bear with me, 53, or any number from 1 to 100, and you start from that point, just say 76. You add 40, and it's 116. You add 40, it's going to be 156, 196, 236, etc. The root would be always an even number. It would always be an even hundreds. Like 50 is going to be 250, is going to be 450, is going to be 850 if you're adding 40s all the way. But let's say you are in an odd number hour. Like right now, 7 is an odd number, and yet you want to use that 53. So what you can do is you can use it, but it's considered half. It's considered like it's only half right, meaning it's not fully there. Because if I take 753 and I subtract 40 from it, I'll get 713. And if I subtract 40 from that, I'll get 673 and then 633. And then what I'll really get is 633, which will be 433, which will be 233. And at the end of the day, it's going to be 33. It won't be 53. But I want 53. So once you get into an hour that's not in its root, which, for example, an odd hour, then you separate. You say, we are 53 minutes in the hour, and never mind the fact that we're not in the right time. You have to know that it's only, I haven't come up with a term for that yet. Maybe it's like half right or something like that. But anyway, no, or maybe it's like, it's called half half cap, maybe that's a good word, half cap. But anyway, the name Landau, and I just came from, I had a connection with that name recently. In fact, I just came back here now, and it was 713. But in the PL-89, 713, when I sat down, I add 40, and 40 plus 13 is 53, but Landau equals 43. I just came from Landau right now. That's amazing. My question is, can this work for everybody? If you go to a party at someone and their name was Sally Jones, or Michael Lipkin, I don't know, or Tyler, I don't know, Tyler Wood, I don't know, but each one of those names have a numerical value. Is there an equilateral application, a universal application to these names? That's what the quandary is. That's what this is seeking to find out. If you could find out that algorithm, if you could find out that pattern, that numerical pattern to all the interaction of names and people, and apply it to different fields, would you have an advantage on the collection of data? And that's one of so Landau is 53, right? And also in the PL-89 and in Gematriona, if someone is named Landau, then every person who is alive on Earth at this time is called Landau, is that Landau. So every and even the people that are not alive. Like, for example, there's an actor named Martin Landau, and Martin Landau, I don't know all the movies he was in, but I know that he did act. He did play Bela Lugosi in Ed Wood, which is like, I just said Wood before, but like Ed Wood, and he played Dracula. He played Bela Lugosi, who was the one who played Dracula at the time of the real Ed Wood. But this one was made in 1994 and is played by Johnny Depp and Martin Landau. Martin Landau played Bela Lugosi. Now, why does that connect to now? Because right now we are in Parshas Vayigash, where Benjamin is the one, the subject of who they are arguing over. That's how that starts out, when Yehuda doesn't know that Joseph is there. He's just the ruler of Egypt, and they are arguing to bring Benjamin back. But what does Benjamin have to do with Bela Lugosi? Because if you read the children of Benjamin, one of them is Bela. I believe that's correct. I'm going to check right now to make sure. Bela. See, Bela Lugosi. He's a Hungarian American. Bela, son of Benjamin. Yes, that's right. That is correct. Bela was the firstborn son of Benjamin, according to Chronicles, 1 Chronicles 8:1. His sons were Adar, Gera, Abihud, Abishua, Naaman, Ahoa, Shephuphon, and Huram. Now, I wonder if Huram is connected to Hiram Abif. That's a whole different thing. But Bela was also the king of Edom, whose city was Dinhabah, according to Genesis 36:32. So when I say Bela Lugosi, I just connected Landau through Martin Landau, but I just ate at someone named Rabbi Yonah Landau. I ate at his house, but I'm connecting that to this parsha because Bela is the son of Benjamin, who they're talking about in this week's Torah portion. So now that I've laid that all out, okay, what we're going to do here is find out where Landau here is here. And so 753. So now you have to go, it's really 653. So 53 really. So it's really 33. You can say if it's in the halfway, it's 33. But if there is, so let's just go regular 50. So 13, right here. 13, right here. Landau's right here. And that is house. I said 22 years. I did. 1322. And 1322 was on the license plate of that truck in that Angel Bakery in Jerusalem in Chanukah on Karen Kamet, 1322. Now 1322 is a big number, but 13 is Landau. Now let's go. Where's the other 13? The other 13 is going to be over here. And I don't know anything about 21 today. Or 4, I don't really know either. But at any rate, that's basically an application. So like, I'm going to look here. I'm going to see 13. Okay, 53 plus 40 is 53. Plus 40 is 93. Plus 40 is 133. So that would take us to 733. But it wasn't 733. It's almost 733 right now. So from 713 to 733. So that 20 is also, oh my goodness, there's so many different connections. So on the half cap, the difference is 20. That would connect to the 20 loaves of Elisha. So there's 20 is a big thing also. And so if it's a natural, it's going to be here. It's going to be 13. It's going to be 13. Okay. Right. Yeah. 13, 53, 93, 133, 173, 213. Like that. 213 and 253, 293. So that's if it's 13. But let's say you want to do 33. The basis would just be actually over here, 24, 33. And you want to start at 33. It's like 33. Well, you won't hit 733. You won't hit 733. If you start at 33, you won't hit 733. You'll hit 633. So I guess 13 is really what it boils down to. It was 713 at the time, but we're looking at 53. So it's like 13. I'm looking at 53, and right now we're in the getter of the Gadarenes. The getter of the Gadarenes means that basically, if you're within 6 minutes, you're within the getter of the Gadarenes. You're right. I'm actually at 733 right now. Even though it's only 727, it's actually statistically, it's like on paper, it's 733.